Hello, viewers. I'm wishing you all a prosperous new year. Here is your mathematics teacher, Engineer Olatunji Olamide, here to take you all on easy steps on how to solve some basic mathematics. So I'll be taking topics one after the other, then solving questions and questions with enough um, with enough explanation to go with it, so that as you are seeing the questions, you can also go along with the explanation. Sorry, for today, I'm going to start with indices. Now, as we all know, indices is one of the major topics in mathematics. And these indices, as you can see, is not as hard as people look at it to be. It's a simple way, a simple subject which I find funny when students find it hard to understand. Now, the reason being that there are some certain rules indices follows. So in this teaching, I'm going to be giving you all those rules and some explanation, and solve some certain questions with you. Firstly, let me go to into introduction of indices. Now, I said indices is writing of numbers in index or power form. Now, somebody will say, "Well, how can you? What does it mean to write numbers?" We all know our natural numbers are one, two, three, four, five. But indices is telling us that there are some certain numbers in those our natural numbers. They are unique. Are we together? They are unique. For example, let's take a 4. 4 is a number in our natural numbers, Abi. Now, I can also write this 4 in index form by asking myself, this 4 is a multiple of a certain number. When I say multiple of a certain number, it means it is gotten from multiplying a certain number. That's what I mean by multiple of a certain number. So for this 4 we have is a multiple of 2 because an even number. Therefore, even number anytime we ask for multiple, you should know it starts from 2 since it's an even number. Because odd number are 1, 3, 5, even number is 2, 4, 6, and so on and so forth. So 4 is a multiple of a number, which is what? 2. How many times that is? 2 times 2 will give us what? 4. Now, remember, this is a number, right? But I want to write it in index form or power form by saying what? 2 multiply itself. How many times? 2, which now give us what? 2 raised to the power of what? 2. So there are some certain numbers, so it's just like writing numbers. So indices can be converted from index form to number, and from numbers back to what? Index form. I hope you are following me. So with this example, let me see another one. We have 27 is a number, but it's an odd number and is a multiple of a certain number, which is what? 3. Now it's asking us that, okay, if it's a multiple of 3, then how many times will 3 multiply itself, no other number itself? Because that's a basic logic of indices. It is multiplying itself. So how many times will 3 multiply itself to give us 27? To look at it, we have to say, 3 times 3 will give us 9. 9 times 3 will now give us what? 27. Now, how many times the 3 multiply itself, which is what? 1, 2, 3. This one will now give us what? 3 raised to the power of what? 3. So you can see it is numbers written in index form. Are you getting me? So that's just the basic logic. Now the major problem why students find it difficult to comprehend now is this: to remember the laws or rules. Because in your natural numbers, we all know 1 plus 1 is 2, 5 plus 5 is 10, 3 times 5 is, because they are following the law of the operation. What are the operation? We have the addition, the multiplication, the division, and the subtraction. So those are the operation of mathematics, and there is a law that guides them. The law of addition says when a one number and a number is added together, you count it together. Abi? The law of subtraction says when a number is removed from another, that is, it is subtracted from it. So also is indices. It has its own rules also, which is very unique if you can just remember them. So I'm going for this video, I'm going to be listing those laws, those rules of indices. Then probably in our next class, then I'll now start making use of one of the indices at a time, then solving multiple questions for you to see that All these things, once you know the laws, once you can apply the rules, every other thing is what? Simples. Now let's move on to rules of indices. I call it rules, I call it laws. Either way, we are still saying the same thing. Now the first one says, now in English class we have to speak English, right? No, 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 no. This is mathematics class, so we don't deal with English. I get me, but we can use English to explain one or two things, but majorly we deal with mathematics. Now, this first one says was when two indices. Remember, indices is when is a number is reaching its index. This is the index. Index, this is or power. This all equals index or power. Why the man here is called the base? Why? Because he's the one that is carrying the index. So this is what we call indices. I hope you are following me. Now, first one says when two indices multiply themselves, that is, if I have a raised power b times a raised power c. Now, what do you see here? The base is a, the index here is b. The base here is a, the index here is c. Therefore, the base of the multiplication must be the same for them to multiply. They must be what? The same. So if the two bases are the same, then what does the law says or the rule says? The rule says where two indices having the same base multiply, therefore the index will add up. A raised power b plus c. It's as simple as that. It's as simple as that. When two a base multiply, the index will what? Add up. That's all. Then we have what? Let me just cite a simple example. Let's say 2 raised power 3 times 2 raised power 4. It's simple. Instead of converting to numbers and start solving, we just have what? Since the base are the same, then we have what? 2 raised power 3 plus 4, which is equal to what? 2 raised power what? 7. Don't worry with times, because I'm going to go deep. Because of I want to help all these WAEC students that want to go for WAEC, so that you can also go online, check on YouTube, and see that all these things are simple. The only problem is you have to just follow the basic principle, which is principle of the operation of indices, which is whenever there is a rule, there is a way to solve it. So there is a rule for multiplication, and there is a way to solve it. That's all. So if you can just apply those rules and memorize them, solving indices will become easier. Let me write another one. Another one says what? When two indices, a raised power b divided by a raised power c, division now. Two indices having the same base, remember they must have the same base. If I'm having a raised power b and b raised power c here, therefore they can't do anything in the indices. But the moment they are having a raised power b and a again, dividing themselves, two indices dividing themselves, having the same base, therefore the law says what? A raised power b minus c. Therefore, the division sign becomes minus, while the multiplication sign becomes what? Plus. Let me cite an example. Just though we are still going to go fully into each and every one of it. Let's say 4 raised power 7 divided by 4 raised power 2. It is simple. Since the bases are the same, we have what? 4 raised power 7 minus 2, which is 4 raised power what? 5. Now, if the answer says you should get it in whole number, then you should know this one means what? 4 multiplying itself how many times? 5 times. Why this one means what? 2 multiplying itself how many times? 7 times. So let's go to that because we are doing indices, that's why I'm leaving our answers in indices. Let's move on. Now this one is very simple, the most unique one. This is saying that anything raised to the power of 0. I'm representing anything with a now. The base has a, but the base can be anything. It can be 1 million, it can be 10 million. But the fact that it is raised to the power of 0, that is the power or the index on it is 0, it is equals to what? 1. No question asked. The moment is raised to the power of 0, it is equals to what? 1. Let's say another law. This one is saying that when an indices is multiplied by another power, take note, not number, another power, This is an indices. This is another power in bracket. This man says what? The two powers will multiply each other. Let me cite an example. Imagine we have d raised to power 3 power 6 in bracket 1 over 2 outside. This is indices. This is the power. Are you getting me? So this simply means what? D raised to power 6 times 1 over 2, which this one is also over 1. You can simply say what? 2 here 1, 2 here what? 3. D raised to power what? 3. You can see that it's very simple and straightforward. It's very simple and what? And straightforward. All you need to do is what? Follow the laws. Once you know the laws, applying them will be easy. Now another one says when a raised to power minus, now the negative sign. No, a raised to power b naturally, a raised to power b naturally is indices. But this negative sign here, it has a meaning in indices. It means what? When we have a minus as power, the minus becomes a fraction, which becomes what? 1 over a raised to power what? A raised to power b. So it is this 1 over that becomes what? That is what? Our minus. Our minus is what? 1 over a raised to power b. We have another one, 6. I think we have like 7 or 8 or 8 of them. We have a raised to power fraction 1 over b. 1 over b. This is a fraction. That is when we have a fraction as the power. What does the law says? The law simply says what? When we have fraction as the power, these fractions become square root. The fraction becomes what? Square root, that is square root a of b. Now the b can be anything. The b can be anything. Let me cite an example. We have what? Let's say a raised to power 1 over 3. That will give you what? Cube root of a. Or let me use another one. We have, let's say this is 1, this is 2. 8 raised to power 1 over 3 equals to what? You can solve this one like saying cube root of 8, oh sorry, 3, 8. Now, 8 is a multiple of something, which is what? Cube root of 2 raised to power what? 3. You know from mathematics knowledge, when the cube and the cube root and the cube are under each other, they tend to what? Cancel out. Then we are left with what? 2. Are you following me? Don't worry, with every loss, we are still going to do a sectional questions on them. I'm going to give you question. I'm going to put question online so that you can also put it in practice. So we have that as our sixth one. Now the seventh one. This man is saying we have what? A raised to power b over c. Now, looking at this man, sorry please, sorry for. Now looking at this man, it is a fraction, but the denominator of the fraction, the numerator of the fraction is just 1. Are you getting me? But in this aspect of number 7, you can see the numerator. This is what we call the numerator. Y here is the what? Denominator. At least most of you that are familiar with fraction will understand that. So this one is having a numerator and a denominator. So I can express the two by saying what? A raised to power b times what? 1 over c. Are we together? A raised to power b times what? 1 over c. If I multiply this, b times 1 will give us b over what? C. Are we together? I think you can still remember. Now remember this law. Law number 4 that says multiplication means what? Indices into bracket what? Power. We can apply that one here now by saying what? A raised to power b into bracket 1 over c. Though I shouldn't be going too slow, I just want to tell you that this is how they got it and everything is very simple. And 1 over c means what? root. So we have what? C root of what? A raised power what? B. So I should have just moved from here to here, but I just want you to see that all these things are just simple explanatory you cannot get and understand. I hope you are following me. Now the last but not the least, though this one I intentionally sometimes don't want to put it, but sometimes I want to put it so that we can all have a basic knowledge. It's just the same thing as this number 7, but only in the fraction form, minus b over c. I've literally told you how to get from this to this. Now all I just have to do is explain the minus, which I've done before when we were doing minus before. So minus means what? 1 over a raised by b over what? C. That's all. Then moving forward, we have what? A raised by b over c is what is 1 over square root c a raised by what? B. I hope you see. So these are the 8 rules, the basic rules of indices. Though when you get to solve like GMAT, Olympiad, though I'm not going there for now. I'm here for the O level students, so that before we then we now move on to the Olympiad and the GMAT exams. But for now, let's deal with the O level result. So with all these 8 rules, if you can see them clearly, with all these 8 rules, if you can see them clearly, are the most important aspects of indices. So if you can master these ones, I can promise you, tackling indices question will just be a walk in the garden. It won't be hard again at all. So I hope with this few explanation that I've been able to pass across to you guys, I will see you guys in my next post and by solving more questions on indices. But for now, let's digest this for today because too much of work might seems too stressful for most math students. That's why I want to make it a step after step. Thank you for watching with me. Thank you for being with me on my post. Please look out for my next post. I'll be doing that very soon. Sorry, I might be busy sometime, but I'll make sure I get across to everybody on it. Thank you. Have a wonderful day.